industry in one of the main first-level suppliers in the sector. I am going to present my current research consisting of the remanufacturing of active power filters of electric vehicles. In this index, you can check the points that I am going to follow during my speech. Among the objectives of my research, the following stand out: a contribution concerning the application of the action research methodology with the use of continuous improvement tools. Also, a contribution is made to the state of the art on the continuous improvement of quality and processes in today's automotive companies, especially on first-class suppliers. Relating with MAHLE, MAHLE is a multinational company belonging to the automotive sector. It acts as a first supplier at Tier 1 for the main car manufacturers, and it is being known as one of the main pioneers and technological drivers of the future of mobility. The multinational is maintaining continuity in the optimization of the combustion engine, but it is also promoting the use of alternative fuels and laying the basis for the worldwide introduction of electric mobility. Therefore, MAHLE has a broad product portfolio addressing fields related to powertrain and air conditioning technology, but also those related to electrical and electronic systems of all kinds. Power filter device is a key component for the management of the battery charge in the electric vehicle engines. It is an electromagnetic compatibility filter that works to avoid the emission of harmonics to the electrical network and possible leakage currents in both alternating and direct current. It shows the better properties to reduce energy leaks and electromagnetic interference and to preserve the life of the electric engine. The power filter device assembly line requires a very rigorous product and process quality compliance in order to satisfy the customer requirements. The manufacturing process of the power filter device requires multiple types of materials. In the image shows a general view of the critical part of the assembly line. Initially, the production process was in a serious situation, with a multitude of errors in different operations and with production times far of the cycle time desired to fulfill the orders agreed with the customer. As in such a complex product, the possibility of remanufacturing it creates special importance. In the face of possible errors within the production process, the possibility of not only disassembly its different components, something that comes from design, but also from the remanufacturing the part. Site remanufacturing must be carried out with a validated process, that is, a serial process, the same as a new part would follow. For this reason, the improvement of the current production processes became vital. Relating to the methodology approach, action research has been chosen as the methodology followed in this case of study for three main reasons. First of all, the theoretical and practical interest involved in applying such a complex methodology, and the contribution to the state of the art justified in seeking improvements in a real production process. Secondly, it is important to highlight the instructive generation of cooperative and participatory work that involves applying the tools used within this methodology. And finally, it is important to say that the researchers have been involved in all the practical work done in this study. This situation, as previously mentioned, is a very favorable point to apply the action research. The first step of the project involves the understanding of the context and the item of analysis, in which it is shown the current situation of the action research topic with which the researcher is performing this investigation. It follows with the action research preparation stage, where the first action steps in the applicability of action research are detailed, such as the selection of the case studied and the selection of the action research team. Then there is the data acquisition stage, where there are described the main groups of information that have been collected in the field to improve the process. After that, in the data study and action preparation section, it is performed an in-depth analysis of the information collected, and after it is done the preparation of the implementation stage. Inside the preparation stage, the action implementation stage, the 4 action research learning cycles are developed, consisting in turn of the 5 stages of diagnosing, action planning, action taking, evaluation, and specific learning. After it is the action evaluation phase, in which there is a complete assessment of the main contribution achieved. This structure is repeated in case of looking for further improvements in the resulting process. This table summarizes the objectives of each learning cycle, the key performance indicators that are worked in each of them, and the tools used for this. As example, there are key performance indicators like the productivity or the throughput time that are critical to can mix the current production with the remanufacturing operations inside the serial production line. Moreover, it has been used tools as the Pareto diagram, 5 whys, process mode effect analysis, 5S, etc., in order to can improve these KPIs. The initial value stream mapping shown in this figure was performed in order to organize the production with the production time with the operations. As shown in it, the desired cycle time was 120 seconds, with most operations being unbalanced and some of them having a high error rate. It was difficult to achieve, and the initial throughput time was 21.27 minutes. Relating to the results and discussion, the application of action research methodology allowed the team to obtain substantial improvements over the starting process in relation to the key metrics defined in this article. In this way, in each for the 4 improvement cycles carried out during the implementation of this methodology, some variables or others have improved depending on the tools applied in each cycle. Mainly, the productivity of the line was increased both by increasing the number of total good parts and reducing the number of rejects, as well as reducing the throughput time and the number of operators needed on the line by balancing the line's operation times. Therefore, after the improvements achieved during the learning cycles, a final value stream mapping of the line is shown in this slide. It has been performed also in order to organize the production time and the operations as a result. As said in the initial value stream mapping, the desired cycle time was 120 seconds. Now it is achieved. And after the improvements with most of the operation balance, the throughput time has been reduced to 15 minutes. Moreover, the number of the operators needed has been reduced from 13 to 9. As a conclusion of the study, it has been achieved the application of the action research methodology to a real factory of a fair level supplier in the automotive sector. The creation of a work philosophy has been deployed in the company, and it can be applied in other production lines. The key performance metrics initially defined have been improved by the learning cycles. The managerial implications have been achieved since the beginning of the research that have been also a key factor. The first difficulties in accepting the change of work way by employees were overcome with the development of the different learning cycles, and there are possible future lines of research with the application of different tools. There are some of the documents that have been used for the development of the research. And that's all. Thanks for the attention, and don't hesitate to ask me any question about that.
Thank you very much.